Hello to all YouTubers. Welcome back to In My Shed. I'm BC, your host. Well, what could go wrong with a simple job like this? Just a threaded a bush for the top of the test boiler, except the flange is supposed to be on this end, not that end. Luckily it's easy to part off and start again, but all things big and small can have a defect. Bring it back when it's ready. Back again. For those of you not familiar with drilling brass, I normally dub the drill a little bit, and dubbing means changing the rake angle, and the rake angle is the flute angle of the drill. So that is the existing flute angle. I use the hand stone, virtually at zero angle or zero rake, and just a couple of wipes on each side till you can see a line of about 1/2 to 3/4 of a millimetre, and that means you've changed the rake angle of the drill. I did use this on the previous piece that wasn't good enough, but we'll give it a go now, drill another hole through it, and you see how the drill performs. Oop, I think my phone's ringing. Righto, back again. We'll give the drill another taste of fairy wheat, and away we go. Just put a little bit of drag on the drill. It seems to be working quite well. Clear it out a bit. There we go, that's a 1/4 inch. You don't have to lube with brass when you're drilling, but I find it stops the drill binding and sometimes shattering. I'm just using 556, which is a kerosene based product. Seems to do the job admirably. Okay, we'll change the tool and bring you back as I part off. Back again. What I have here is an upside down parting pole sold by Gary at Eccentric Engineering, New South Wales. Solves a lot of parting problems, but being brass I still go steady eddy, little bit of fairy wheat, and away we go. Slowly crank it in. And I hope I don't give you anything exciting to see. But the brass parts off quite nicely. A bit more lube. And provided you don't get into it, and give it a lot of feed rate, it parts off quite nicely. Gary calls the tool a cobalt parting blade, which I think assumes it's got a little bit of cobalt in it, and that could be correct. I know it grinds a little bit easy for high cobalt tool. In a big lathe like the Mazak, parting off shouldn't be a problem anyway. And we'll try and catch it. Whoa! All in one item done. I'm just doing this the old-fashioned way, spring-loaded tap centre, quarter BSPT tap, and a little bit of fairy weave up inside the brass. As with all tapered pipe fittings, you run the tap in until there's about 4 or 5 threads left on the tap, and then you've gone deep enough. If the tap feels like it's getting a little bit tight, I'll wind it back out and clear the threads. So far so good. It's getting a bit tight now. You can see the brass choking the tap up a bit. And a little squirt. Brass is fairly free machining. Matter of fact, your other copper-based alloys usually have their machinability expressed as a percentage of the ability to cut free cutting brass. Now the tap's through the bush and the swarf is coming away fairly free. Now that's about the point where I'll stop. There's about 5 threads showing there. If in the future I find that's not sufficient, it doesn't take much just to put a tap in and take a little bit more out. But that usually gives you the correct depth of thread for a BSPT fitting. Okay, all for now. And now for a word of caution on brass fittings. After espousing how many threads of the tap should be left proud, I went to screw this brass fitting in just as a test, and it only went in about 1.5 turns, and I thought, bugger. So back in the lathe, I screwed the tap in another couple of turns, and a little light bulb come on. How about we try the test fitting on the hydraulic test rig? So I took this brass fitting out, and luckily I hadn't gone down another thread or two because it's now just a fraction over deep on the fitting on the test rig. So all brass fittings are not created equal, and this one seems to have a slightly larger diameter thread than I expected. So always check where you're finally going to use it. And I think that I was fairly close, maybe 3 to 4 instead of 4 to 5 threads showing. Back again. Well everybody, back again. This has been the most nervous part of the deal so far. This copper is ooey gooey and difficult to cut at the same time. I finished up putting this cone drill in. If I can get it to spin a little bit, you'll see it's pretty well straight flute, so the rake angle is very, very low, and it doesn't have much of a positive grind inside the flute. Only running at this speed and using my terrific coconut oil based anti-spatter as a lubricant, it was really touch and go. I've just got it mounted on a piece of wood with wedges driven in both ends. There's no better way that I can clamp it because I don't have V-block fixtures that big, and I can't distort it by more than 1% or it goes outside the code. So that was probably at least 5 minutes drilling that tentatively, stopping 2 or 3 times each step to add a bit more lubricant. And it's a real touch and go. You put more and more pressure on, and then the drill would surge forward by 0.5 millimetre, and every time it squawked I'd have to stop and put some more lubricant on. But lo and behold, 2 jobs done today. I might clean it up a little bit in case I can get it brazed next week by Rowan. He's going to do the TIG welding on one end and I'll do the MIG welding on the other. And it's starting to look like we're getting closer and closer to success. So I think we've got enough area under there to silver solder to hold it. It'll be interesting to see what pressure it blows up at. But that's all for today. Housework beckons. See you later. Oh, don't forget, like and subscribe, please. Here I brought you out to the Brierly drill grinder. I thought after I dubbed that 3/4 inch drill for brass, I'd better put it back into steel grind. And the old wheel here was a little bit glazed and crappy in the middle, so I've inserted the diamond dresser into the chuck and now winding it across the face of the wheel. So you can see the colour of the wheel change as I dress the old surface out. And I also make it flat across. It doesn't have a great big hollow in the middle anymore. And I did notice that with the much shorter dressing tool, there's less vibration on this one. Okay, that's the wheel dressed. I'll now swing the main body of the grinder back around, put the drill in and give you a look at grinding a drill on the Brierly. Well, this is the operating side of the Brierly drill grinder. Let's put a bit more light on the subject. Okay, that's a bit better. And I'll run you through a little bit of the setup. Here we have the cam that operates the cam lever. This is the cam ring that receives the motion. That's the chuck. Now to set the drill up in the machine, you have a reverse conical section on the end of a handle up the rear of the shaft, and that contacts the back of the drill and centralises it. Even with the 6-tool chuck you can be out a little bit. Now this setting plate is marked off virtually in 1/16 increments. So you bring that around to the front. I've scribed 2 lines into the backing plate here that the setting gauge comes across to. And the reason I've done that is I believe that the crank handle and the main body is not timed correctly inside. I found this position to be the one that works. So you set your drill on the diameter per 16th out to the corner of the lip. Rotate the drill until the lip touches the gauge on a little step, and then tighten up the chuck. Pull the gauge out of the way, and this is your clearance ring. You then adjust this around to how much clearance you want to put on the drill against that scale there. Now as you turn the handle, it brings the cutting lip up into engagement with the wheel, and this cam pulls the body across and pushes the drill in so it grinds on the heel of the drill. Now you may not be able to see it, but there's a very, very faint silver line on the cutting edge. That's how much I dull the edge or dub the edge for brass. You don't need to do it much at all. Okay, we'll start the machine up and try and put a brand new edge on this drill bit. Just bring it back a bit more towards the centre. So a little bit noisy, but we'll give it a go. Now it is. Now I'll move you around to the other side and put you in my way, but you can have a look at the action of the mechanism from over here. The very weird thing to watch. Right, a little bit of zoom in. That's about it. Now I suggest you watch the movement of the cam plate as it pushes the drill forward and the way the drill rotates and moves in to give it clearance behind the land. Now this plate moving in and out corresponds to the cam over here, and the cam operates twice per revolution of the drill. I'll just check the back of the land. Still need a little bit more. Bring you back into focus. And there you can see why I prefer to grind my drills mechanically if I can. Now luckily this web is still reasonably thin, so I don't have to web thin it, but there's still a little bit left on from the last time I did for a special job. But this Brierly does a pretty nice job. Okay, bye for now.